Hello everyone, welcome to today's class. In this lecture we'll do a subtopic of vectors, that is cross product. Again, very straightforward topic, very much relevant here. Okay. So let's look what does a cross product look like, what are the properties related to it. We'll make the notes. So first of all, it is represented by A vector cross B vector. Okay. And if you want to calculate its magnitude, it's mod A mod B sine theta. Dot product opens with cos, cross product opens with sine theta. Same thing where theta is angle between two vectors. Okay. Second thing, A cross B, it gives us another vector, let's say C vector. Okay. So first of all, A cross B is a vector quantity. Dot product gives a scalar quantity. Okay, it's a number, whereas cross product gives you a vector quantity, where C is a vector perpendicular to both A vector and B vector. Okay. So if you ever need a vector which is perpendicular to two given vectors, what do? You find their cross product. The cross product will give you another vector which will be perpendicular to both A and B. Okay. Next is, how do we actually calculate the vector then? Okay. We calculated the magnitude, but we didn't calculate its exact vector. So A cross B actually is given by ijk, determinant of ijk, A1, A2, A3, B1, B2, B3. Okay. What are A1, A2, A3, B1, B2, B3? They are components of A vector and B vector. I'll put it here. A vector is A1i, A2j, A3k, and B vector is B1i, B2j, B3k. Yeah. So very much relevant, this thing. And more importantly, remember that cross product, it will be slightly lengthy to do. It will take time, and be very careful, because this is the part where it goes wrong mostly. Any question related to cross product goes around this. Okay. Mistakes usually happens in opening this, and just have the tendency to open it along the first row. Okay, plus minus plus ijk directly you will get. Don't try to open it along this column. Okay. All right. Now this cross product, this is not commutative. Means your A cross B and B cross A both means different thing. So if you are doing A cross B, so you'll write the row of the components of A vector first and then B vector. However, if you are doing B cross A, then you'll write the components of B vector first and then A vector. So basically, if B cross A has to be done, this two rows R2 and R3 must be interchanged. What happens if you interchange rows of a determinant? The sign becomes negatives. Okay. So this is from the properties of determinant, that A cross B and B cross A, they are just opposite. Okay. They are equal but negative of each other. Okay. So not commutative. This is not commutative. All right. Usually they'll not ask you sign of they'll not ask the angle between two vectors using sign, but suppose the question is forcing you to calculate sine of two angle between the vectors. So sine theta again can be calculated by A cross B upon mod A mod B. Okay. Magnitude of A cross B upon mod A mod B. But again, very rarely, very oftenly it will be used. Okay. So if they really want you to calculate the angle, it's better to use cos. Dot product is easy, cross product is lengthy. Okay. Then comes a property A cross A. A cross A, like A dot A, na? A dot A was mod A square. So A cross A, let's say this is a vector A, this is another same vector A on this, okay, another vector A on this. So angle between them, there is no angle right now, so they have theta is 0. What is sine 0? Sine 0 is 0. So remember that A cross A is a 0 vector, null vector. Next is distributive properties are still applicable, so not commutative. I'll write here, not commutative, but distributive is there. A cross B vector plus C vector is equal to A cross B plus A cross C. Okay. Cross of A with B, cross of A with, my bad, C. Okay. Next property. Suppose two vectors are parallel. Okay, like this. A na. Both A vectors were, actually they were same vectors, but let's say two vectors were parallel. Still the angle between the two vectors will be 0. So in that scenario, theta will be 0. Okay. So if two vectors are parallel, so condition of parallel vectors or parallel lines, condition, you might think why I'm saying lines, because the next chapter in that you'll study is 3D, and in 3D vectors are used to represent lines. Okay, so condition of parallel vectors is A cross B is equal to 0. Okay, the cross product should be 0, but you should also know that if two vectors are literally parallel, we can directly say A is lambda times B. Okay, this is I've already discussed in the first lecture of vector, that if two vectors are parallel, then the ratio of their components A1 by A2, A1 by B1, A2 by B2, A3 by B3 must be equal, or shortly I say like this, A is lambda times B vector. Okay, so remember that cross product is 0. Yes, that's true, but this is much faster to do. We'll see an example based on this. Ninth. All right. Parallel. They can also use one word, collinear. Okay. Collinear also means parallel or anti-parallel. Na? Anti-parallel means theta 180. So theta, even if it is 180 degree, sine 180 is still 0. So still the same condition. So whether they say parallel vectors or collinear, it's true. Okay. Now comes application part. Let's take a parallelogram. Condition of parallel. Next is area of parallelogram. Suppose you take two vectors, A vector, B vector. Remember we used to do, I taught you addition of vectors. It was like this, na? The diagonal of this parallelogram will be your resultant A plus B. So suppose you want to calculate the area of that parallelogram, area. So in that scenario, area is given by magnitude of A cross B. Okay, so the cross product gives you the area of parallelogram that is created like this in terms of vector. Next application, we can calculate the area of triangle because triangle of vector addition was also there. Yeah. So let's say this was on a one vector, A vector, B vector, and if we join the resultant, it results like this. third side, A vector, B vector. We want to make the calculation of the area. Again, this area is also given by area is equal to, this time it's just half of A cross B, magnitude. Okay. All right. Done. Now let's talk about IJK. One second. Hmm. 11th. So we're going to start with I cross I. They are pretty much same as J cross J, the same as K cross K, I, J, K, and there they are 0. Reason, A cross A is 0, na? A cross A. So whether it's I, J, J, K, K, everything is 0. As long as you have two same vector, the cross product is 0. Okay. Next. 12th. We'll do it here only, no need for 12th. What if it is I cross J, J cross K, K cross I, and what if it was reverse, J cross I, K cross J, I cross K. Okay. Now for this you don't have to learn 6 different results. You have to remember this diagram. I, J, K, and this sense of direction. Okay. So let's see how this helps. I cross J, from I to J, move from I to J and jump to the next one, that's K. Okay. J cross K, move from J to K, move to the next one, I. K cross I, start from K, move towards I, and then jump to the next one, that's J. So simple enough. Then what happens with J cross I? So same circle, J cross I. You are moving opposite to the direction that I have mentioned. So whenever you are moving opposite to the direction that I have mentioned, you have to put a negative sign. So J cross I, move to the next one, K, but it will be minus K because we moved in the anti-clockwise direction, not the clockwise. K cross J. So K cross J, again from K to J, we are moving in clockwise direction, opposite to this direction. Sorry, we are K to J, we are moving in anti-clockwise, opposite to this. So K cross J will be, next is I, but minus I, opposite. Similarly, I cross K, move it to the next one, J, but since you are moving in opposite direction, you put a negative. So no need to learn these 6 results, the later ones specifically. The first one you can relate it with A cross A. These second ones, these 3 and 3, 6, you relate it with this diagram. One single diagram, 6 results. All right, this is done, this is done. Yes. Now let's start with the cross product. So very straightforward question. You literally have to calculate. A vector is given, B vector is given, you have to calculate the mod. Okay. Now you might think the mod is asked, magnitude is asked, that means what we have to do? Mod A, mod B, sine theta, but theta is not given. Yeah. So in that scenario, what you do? You start by doing the actual cross product, means you actually calculate your A cross B vector and then we'll calculate its magnitude. So let's calculate A cross B. So magnitude I, J, K, determinant of, then A vector component 1 minus 7, 7, second one, B is 3 minus 2, 2, and we expanded about this plus minus plus. So I into minus 14 minus of minus 14, that's coming 0. Okay, then minus of j, you open j with negative, so cancel it again. It will be 1 into 2. Yeah, so you need to have the idea of determinant. In case you don't have the idea, I'll show you from the basic. So if you are opening about I, leave the row, leave the column, leave the row, and then whatever is 2 cross 2 left, this is 2 cross 2, minus 7, 7, minus 2, 2. You have to open this. Then minus j, opening with, first I is opened with plus, j is opened with minus, this is opened with plus. Okay. Then you do it with j. So j, determinant of 1, 7, 3, 2, plus k you have to open, and that is with same process for j. You leave this column, you leave this row. So that is 1 minus 7, 3 minus 2. Okay. So I into this determinant, how do we solve this? Multiply cross product and then subtract from another cross. So minus 7 into 2, minus 14, minus of minus 14 plus 14, so this becomes 0. Then 1 into 2, 2 minus 21, so you get minus 19, so plus 19j, plus this one is minus 2 minus of plus 21, so that is also minus 9 minus 19k. Okay, so 19j minus 19k, I is component is coming 0. Okay, weird values anyway. Now you have to calculate magnitude of it. So how do we calculate magnitude of it? Okay, in order to calculate the magnitude, you do square root of each component square. So 0 square plus 19 square plus minus 19 square. I think 19 square is same, so take 19 outside. 1 plus 1 root 2, so 19 root 2 is the magnitude of this. Okay. Yes, slightly lengthy, you can see. You have to open the determinant and be very careful. I've shown multiple steps. If you are comfortable, no need to write it like this. Directly calculate your IJK accordingly. Okay. All right, this is done. Let's look at the next question. All right. Next question is sort of theoretical in sense, but you'll see the essence of it. Okay. A minus B, A plus B, and there is a cross product. I told you that in dot product, while we were doing dot product, I told you that you can use the property of algebra. Suppose you use property of algebra here also. Okay, so that will be resulting in A square minus B square. But that's not the result he's asking. Okay, so how do we get this result? You literally multiply A with A with B using the distributive property, and then you multiply B with A minus B with A, then B with B. Let's do it. So A cross A plus A cross B. First we have done with A, now do it with B. Minus B cross A minus B cross B. Okay. What's A cross A? 0. What's B cross B? 0. Okay. So what we are left with is A cross A No, this is 0 now. So what is left is only A cross B minus B cross A. And you know from the not commutative property exactly, B cross A is just opposite of A cross B. So if I want to convert this, I can convert this A cross B into A cross B. Okay, B cross A is minus of A cross B. So negative negative becomes positive. So this is 2 times A cross B. Okay. So remember that while doing the products of vector, see whether it's dot product or cross product. Dot product you can use algebraic properties, but cross product they don't work. Okay. All right, this is done. Now let's see one question. This is okay question. The question says find lambda and mu. Okay. It is given that this vector cross this vector is a null vector, 0 vector. There are 2 ways to do this question. One I'll show, another one I'll give you the approach, but I'll not solve it. Okay. Okay, let's see it. So if we literally calculate the cross product of it, okay, the lengthy approach, I, J, K, 2, 6, 27, 1 lambda mu. Okay, we'll get some sort of a vector I into something, J plus, let's say J into something, plus K into something. Now the vector is 0, so this component should be 0, this component should be 0, this component should also be 0, and you can get the value of lambda and mu accordingly. That's a lengthy approach. Let's look at a short one. If you are doing cross product and it is coming 0, what is the interpretation? That the 2 vectors are parallel. If the 2 vectors are parallel, what is the condition that I told you? That A is nothing but lambda times B. Okay. Or the other way to say is A1 by B1 is A2 by B2 is equal to A3 by B3, means the component should be in the ratio. Okay, look at the ratio, 2 here, 2, 1. Okay, so 2 ratio 1 or 2 upon 1. The second ratio, 6 lambda is equal to 6 by lambda should be here 27 by mu. 27 by mu. Solve these two, you'll get lambda as 3. Solve these two, you'll get mu as 27 by 2. It's as direct as that. Okay, this is the short way to do it. This is a faster way to do it. It's just that concept is required, that if the cross product is coming 0, the vectors are parallel. If the vectors are parallel, we can use the condition of parallel vectors. Lambda times A vector is lambda times B vector, or the components are in ratio. Okay. You can literally do this without even writing this. Just look at this. 2 is getting 1, means you have multiplied by half. So all the factors should be multiplied by half. 6 should be multiplied by half. 27 should also be multiplied by half. That's the meaning of A is equal to lambda times B vector. Lambda is your multiplying factor. So 1 by 2 is your multiplying factor. Okay. So directly you can get the value of lambda and mu without even writing anything. All right. This is done. This is done. Let's look at next question. Next question, slightly lengthy again, pretty much I'll say conventional sense of question. Okay. It's given you 3 vertices A, B and C. is asking for the area of triangle. All right. Okay. So for this question, if he's asking for area, of course you have to do the cross product, okay, because area of triangle is given by half of A cross B. Okay, let's say this is A, let's say this is B, let's say this is C. Okay, so 1 comma 1 comma 2, 2 comma 3 comma 5, 1 comma 5 comma 5. Okay. Now you know you can calculate your AB vector, you know you can calculate your BC vector. Okay, how do we do that? A vector minus B, AB vector is given by B vector minus A vector. Okay, one comma 1 comma 2. So B minus A. So what you can do is don't even write B vector, directly subtract them. 2 minus 1, 1I, 3 minus 1, 2J, yeah, and 5 minus 2, 3K. Okay. Similarly BC vector na, so C minus A. So 1 minus 2 minus 1I, 5 minus 3 2J, 5 minus 5 0K. Okay. Now that you have got the two vectors, okay, these two AB and BC, although I have calculated AB, that means A to B, B to C, doesn't really matter because we are calculating area. Effectively the area is a scalar quantity, it has to be positive. Okay, so in that scenario I should have taken BA, but I'm taking AB, still it won't affect the answer. Okay, so even if you take BA or you take AB, still the answer is same. So area is half AB vector cross BC vector. Okay, magnitude of that. You know you have to do cross product. Okay, 1 by 2 I j k 1 2 3 minus 1 2 0. Solve it. 1 by 2. Okay, and calculate accordingly what is coming. 1 2 3 minus 1 2 0. So it is coming, let's solve it. It is coming 0 minus 6 minus 6I. Okay, minus 6I, minus 6I. Then for minus j it will come 0 minus minus 3, again 3, plus k into 2 minus minus 2, so 4. Okay. So, and we have to calculate, basically this is the vector now, so we have to calculate the magnitude of it to get the value of area. So calculate the magnitude of it. So magnitude will be square root of 6 square 36, 3 square 9, 4 square 16. Okay, so 36, 42, 52 root, it is coming root 61. Okay, so it is coming root 61 by 2 square units. Okay, that's pretty much regarding how to calculate. This is a very lengthy question because they asked you to calculate first of all the vectors and then do the cross product to find the exact area. Okay, but still, if you are fast enough, you can do this quickly. Alright, let's look at another question. This is a pretty easy question, straightforward. The question says you have to do k cross j dot I plus j cross k. Okay. So dot and cross product both are involved in, but let's do the cross first. So k cross j. So remember the circle I, j, k. So k cross j, and the circle was for clockwise. So k cross j will be minus I dot I plus j dot k is dot product of j dot k is 0. I dot I is minus, this is 1. So answer is minus 1 for this. Alright. These kinds of questions can be created. Now next is scalar triple product. Okay. So scalar triple product, I'll give the basics. Again, problem with the scalar triple product is it's slightly lengthy to calculate. Okay. But sometimes the questions are asked based on the properties. So let's go through what is the representation and what is the overall idea. Scalar triple product is basically A dot B cross C. Okay, but it is represented like this: A, B, C. Okay, so instead of writing dot and then cross, directly we say A, B, C. Okay, in this notation. Okay. Now let's look at the properties of it. So basically, this is your scalar product, and this scalar triple product. And A dot B cross C, suppose you have to do this. So you can directly do this by doing A1, A2, A3, the components of A, then B1, B2, B3, then C1, C2, C3, determinant of this. And now you can see why this is lengthy to actually calculate, because you have to open a determinant properly, okay, with values. So in order to calculate, what do? We write the components of A first, then B, and then C. Now, if you move A, B, C in cyclic order, if A, B, C are moved in cyclic order, then scalar triple product remains same. What is the meaning of that? Meaning is, let's say A vector, B vector, C vector. Okay, and what I'm doing is moving this here. Okay, I've taken A in front of BC. Okay, so B, C, A. Even if I do this, it is still the same. Okay, I'm moving in cyclic direction. Okay, then I'm moving again B, and I've taken A, C and A before. So this is C, A, B. If I again move C in this direction, I'll get back to your ABC. This is the meaning of moving the vectors in cyclic order. So even if the position of ABC are changed, you have to see for yourself whether they are moved in cyclic order or not. Means something is moved, but it should get retraced back to itself effectively. Or the way to move is like take A, move it in front of BC. Take B, move in front of CA. Take C, move in front of AB. Okay. But if the order is changed, okay, let's say A, B, C. Okay, this is one result of it. The another result is if A, B, C, suppose you changed B and A only, B and A, C. As such, both result will be same. It's just that one additional negative sign will come. See, this time I have not moved in cyclic. I should have moved A after C, but I have replaced, or I have put A between B and C. Okay, so in that scenario, this happens. Or you can understand like this. Basically, if I'm writing BAC, then I'll write the component of B vector first here, then A vector. If two rows are changed, again the determinant gets negative sign. Okay. Next, if two vectors are same, let's say out of these three, it is done for three. Let's say you have done it for A cross A and B, or you have done it for B, A. Okay, any two can be same. Okay, C, B, C. I'm just saying any two vectors are same in any position. The point is that if you get to the determinant part, you will get two rows same. If you get two rows same, the determinant is always 0. So if two vectors are same in scalar triple product, the result is 0. Okay. Fifth, what does it actually gives? So in 3D it gives volume of parallelopiped. What is parallelopiped? Think of a cuboid. It's just that all the heights are like 90 degree. You slightly tilt them. Okay, that's a parallelopiped. Okay, so volume of that shape is given by A, B, C. Okay, if A vector, B vector and C vector are sides of parallelepiped. Okay, next, this is what we have talked about. Let's say if three vectors are coplanar. Coplanar means they must lie in the same plane. Okay, although we have not studied 3D right now, this condition, I'm not going to explain how this is working. I'm just going to give you the condition. The working will come in 3D. Okay, so three vectors A, B, C are coplanar. Or I'll write like this: condition of coplanar vector, like condition of parallel line, condition of perpendicular lines. So condition of coplanar vector. Coplanar vectors means all vectors are in same plane. Is A vector, B vector, C vector. Scalar triple product should be 0. And lastly, condition of 4 points coplanar. So if you have 4 points A, B, C, D, okay, A, B, C, D, 4 points are there. Okay, you have the coordinate for it. In that case, you create vector A, B, B, C, C, D, D, A, whatever you want to get. You create three vectors out of it, any three vectors. Okay, so I am writing A, B, A, C, A, D, but it is not the only condition. I am telling you, you can take any three vectors in that. Okay, you can take A, B, B, C, C, A, C, D also. Okay, not C, A. C, A and A, C means same thing. So A, B, B, C and A, C, B, D, anything. Okay, you have to take three vectors from these 4 points. So for simplicity, I have considered A, B, A, C and A, D. The scalar triple product should be 0. Okay, these are all the conditions related with the coplanar vectors and coplanar points. Most of part of it will be discussed in 3D. Right now these conditions should be clear, and how to calculate scalar triple product, that's much more of relevance here. Okay, all right. I think that's it. That's all for vectors. We have discussed the basic thoroughly. We have discussed how to do dot product, cross product. That is much more of relevance. Also we have done direction, cosines and direction ratio. These parts will be extended in 3D. Okay, so go through your basics, get comfortable with dot and cross product. Okay, the scalar product, triple product, don't get worried. Once the 3D will begin, this conditions will be able to understand why they are 0 also. Okay, all right, that's it from my end. See you in the next class. Good day everyone. Bye.